design criteria. If you talk about how we typically approach it as engineers, probability of occurrence versus design life. If it's a 50-year design life for a structure, we look at certain, slope stability parameters, we look at other things, we look at risk versus consequence. But what is different is that almost all of these have been codified in some form or the other, in building codes, in architectural guidelines. An example would be the earthquake risks. They have been classified, and there are risk classifications, high, moderate, and low. And if a terminal, this was done for the marine oil terminal, receives quite a bit of traffic, then it is classified as a high risk. And so there are certain classifications which in the statistical lingo, it comes out to probability of occurrence or exceedance within a given time span. And these are the kind of return periods that we design for normally. 72 to 475 years, which is, 72 is a pretty small number. I mean, that is a number that you would not want your house to be built for, because it's an earthquake risk of 72-year earthquake. 475 is more like it. Bay Bridge was done for, I believe, 2,500 years as a return period. So what's different about sea level rise? There's a lot of uncertainty, a lot of skepticism. Is it happening? We've seen only a few inches over the past 100 years. We're talking about meters over the next 100 years. So there's a lot of skepticism. There's a lot of doubt, a lot of model building upon each other to get you the results. And so, what are the true numbers? And there is no guidance. There isn't enough certainty in this process to support codification. How much should a building on Sutter Street be kept at in terms of finished floor elevation that San Francisco Building Department would give you a permit on? It's not there. When we look at the actual science itself, this is what we have observed. This is data. Green is data. And if you project that data out 100 years, that's 8 inches. 1990, this is 2100, that's 8 inches per century. The last 30 years or so, there have been high altitude measurements done from satellites, very high precision. And what they have been also noticing is that if you look at the rate of sea level rise, and if you take the average, which is 2 millimeters per year, which is what 8 inches per century works out to be, it's kind of double. And so they're seeing rates of 4 millimeters per year. It's not enough, it's only 20 years, but if you project that out, you get a much higher line. And then the Intergovernmental Panel on Climate Change had been working together, international bodies of scientists from all the countries, meeting annually, and they came up with their scenarios of emissions and correlating CO2s and emissions to sea level rise. So they came up with some different numbers. Again, the numbers were maxing out at about 36, there's about 3 feet over 100 years. But more and more studies kept coming along. These studies that really the state of California have built their entire adaptation strategy and guidance process has been around the work done by Bronsdorf. And that's where he was the one who first came up with a estimate of 55 inches by 2100 as being the most likely number. On the high side, but likely number. And about 16 inches or so by 2050. That was in 2007. You look at what's just happened, NRC, which is the National Academy of Sciences, came out with their study for California, Oregon, and Washington. The range is much higher than even what existed back then, with a projection at about 3 feet. IPCC has come out with various reasons for why and how this thing. So, but if you look at West Coast versus East Coast, there's a very big difference on what we deal with here in California, Oregon, Washington versus the Atlantic, which deals with hurricanes and surges, which we don't get here. So if you look at just what do we normally have to account for to elevate your shoreline, our tides, which are about 2 meters or so along the coast of California, about 6 feet tides. Storm waves, depending on where you are, up to 4 meters. Sea level, right? When you look at it, that's a tiny number. Anomalies in sea level, your El Niños, your La Niñas, your PDOs, and then storm surges, which come along. 2100, assuming that storm waves and tides don't change, which the jury's out there whether it will or not, the sea level rise increases, 1 to 2 meters. West coast versus east coast, that's pretty much it. It's tidally driven and wave driven. On the east coast, you've got your surge and tide, and then this is your waves. So quite different approaches need to be adopted. When you look at California, typical bluff situation, Monterey, Point Reyes, Santa Cruz, you're looking at your sea level, mean sea level today. The projections, are just the mean sea level is what this would be in 2100. You put in waves on top of it, you put in El Niños, anomalies, these things keep rising quite a bit. And so if you look at 2100, we're talking about numbers that are very high, and much of California is not protected to even these numbers today. And so therefore, after a storm, you see flooding. High tides, king tides, you see flooding. And so I say here, how will sea level rise first present? So it's not going to be like your tsunami wave coming in. It's not going to be 2 feet of water. You're going to start seeing increased flooding. So what happens once a year will probably happen every full moon and every new moon, which is 3 and 3, maybe 6 days a month instead of once a year. Increased overtopping from storm waves. So along the coast, you're going to see most of the piers and stuff will see these kind of waves. Increased vulnerability to tsunamis, because the tsunamis kind of ride on top of a tide. Tsunamis, which we've had 3 large tsunamis, very large earthquakes that have hit the Bay Area, or rather affected the Bay Area. All have been offshore, including the Japanese one and the Alaska one. But they've come in at a time where the high tide is, it's your normal high tide, 4 to 5 feet. And so the tsunamis have presented themselves just as a really high tide and very strong currents, which have let loose boats out in the marinas. But this is what you would probably see more and more of in terms of what would happen. And loss of FEMA, this is what has already happened. Redwood Shores lost its FEMA protected status. All of the Shores Peninsula residents were obliged to purchase flood insurance. The city, of course, worked super fast, 24/7, and fixed all these levees to know that happened. So now when you look at the bay, you've got a 6-foot tide range. This is